quickly, just remember when we solve these, our goal is always to isolate the variable. So we always want to get the variable. That is our goal 100% all the time. We do that by undoing things to get that variable alone. So we just want to undo the inverse operation. So we do the inverse operation, the opposite operation to do that. So quick reminder, most of you know when I ask you this kind of stuff, adding and subtracting are opposites, right? And multiplying and dividing are opposites. So that is usually, everybody gets that pretty well. The thing that we sometimes forget is that we always have to do the same thing to both sides. That's not what I want. Where's this? This right here is super important. And the thing we forget most often is that idea of both sides of the equation. So when I'm solving, here's what I would suggest you do. I want numbers and variables on separate sides. Pick which side you want them to be on. Oh, anybody want to know hot dog names of 2018 from Ottawa County? Excuse me. So pick a side to move them to. I don't care. It doesn't matter. Sometimes it makes more sense to move to one side or the other, but you can decide. The other thing I would suggest you do is if you have a hard time seeing which side is each side of the equal sign, draw a line through the equal sign, and those are your two sides, of your left and your right side. Right? So when I solve this, I usually look and say which side is going to keep my variable positive if I can. Right? I like to have positive numbers, especially with the variable. So I look and notice that I have 2 x's over here and 3 over here. So it's going to make sense to move this 2 over, because then I'm going to keep things positive. So if I do that, I have a positive 2x. Think of that as adding. Sometimes if it's not written in front of it, we struggle with that. So if it's positive, I think of it as adding. So I do the opposite, take away 2x, and I have to go to the other side of the equation. I have to go to the other side of that line. Then I look at that and say, okay, I'm going to do that. 2x minus 2x reduces to 0. I bring down that plus 5. And I look at the other side, gives me 1x, and I bring down my plus 3. So now when I'm looking at this, I notice that I have just numbers on this left side, right? And I have x's and numbers over here. So that means my number is my problem. So the same kind of thing. So now I want to get that 3 and I want to move it over. So I need to do it to each side. 5 minus 3 is 2. And then 3 minus 3 reduces to 0. So we're done there because I know what 1x is. That's my goal, is to figure out what is 1x. So that one's all set. Sometimes you have multi-step kind of thing. So that was a 2-step, 3-step equation. You'll have to get rid of the parentheses first if you have that. So we want to distribute that 3, right, to both sides, both things inside. So I'm going to leave this side completely alone. That negative 27 plus 6y. I'm going to leave it alone. I'm going to distribute that. So I have 3y minus 9. So now I want to draw my line and solve. So, Scott, which side would you move the y's to, left or right? Which side would you move the y's to? What? Which side do you want to move the y's to? What makes more sense to you? Left or right? To have them end up on? Why? Okay, right? If I look, good. 3y is smaller than 6y. So if I subtract the 3y, that keeps things positive. It's what I like it. I like it because it keeps things nicer. So if I do that, I'm going to take this negative 27, I'm going to carry that down. All right, 6 minus 3 would give me a positive 3y. 3y minus 3y reduces to 0. I have minus 9. So now I'm back to that whole idea where I have only numbers here, and I have both here, so I want to get rid of the numbers here. So if I have a negative 27, I need to think about what do I have to do to get that to 0. So I add the opposite. So I'm going to add 27. Add 27. So that reduces to 0. Still have my 3y equals. Then if I do negative 9 plus 27, you get 18. Here's where you sometimes have one last step. So I want to know what 1y is. So this is where you need to remember that anytime it's written 3 and then a number, or a number and then a variable, it means multiplication. So to undo that, I want to divide both sides by the coefficient. So I always divide by what the number is in front of the variable. And if you know that, great. If you want to use the calculator, so y is equal to 6. All right. What's my first step have to be here? Distribute. I'm going to distribute that 4. I don't know why I keep trying to really get it. So 4 times x will give me 4x. 4 times negative 5 give me a minus 20. And I carry over the rest. Okay. Fisher, what would your next step be here?
Subtract 2 from itself and
2x, right? I want to be specific. So I want to move that 2x over, keeps things positive. So end up with 2x minus 20 equals 60. Scott, what would your next step be? So I'm going to add 20 to both sides. 2x is equal to 80. And then I just want to divide by 2. So x is equal to 40. Good. One last thing, and then I'm done talking. You might have to check if something is a solution, right? This could be really helpful. Say I'm very nice and give you an equation to solve. You can just plug in variables with multiple choice and see if it works. It might be easier to do sometimes. But so when I want to do this, it's just like evaluating expressions. It's what we did yesterday, right? So like this asks you is if check to see if x equals 6 is a solution to that 2x plus 5 equals 17. So to do that, I just want to plug in the value of the variable. So that's like my first step here. So I'd say, well, is 2 times 6 plus 5, can I do a question mark there, is that true? And I'm going to evaluate the expression. So I'm just going to do my order of operations. So 2 times 6 gives me 12. Still have that plus 5 there. So I evaluate it, finish it. So I know, is 17 equal to 17? Yes, right? So you can say x is a solution. So that's all that means.